This video is a video for coordinate geometry of the line. It's looking at coordinate geometry of the line worksheet number 2, and it's all about finding the distance between 2 points. So of course, from the first video we were looking at the coordinate plane, and the coordinate plane we have our x and we have our y axis. Again, we should be perfectly fine now at this stage at plotting points. So if this point is 1, 1, and we have the point here, which is -1, -1, we should be fine at plotting those points. And what we need to be able to do now is we need to be able to find the distance between 2 points. So for example, what would the distance be between 1, 1 and -1, -1? This worksheet is all about doing that. Now, we're quite lucky because the distance between 2 points formula is on page 18 of the formula and tables booklet, and it's also here in front of you here. So here's the formula, which you will see on page 18 of the formula and tables booklet. So anytime you're asked to find the distance between 2 points, you just use this formula, you fill it in, and that's going to be your answer. So, no, the distance between points A and B is the same as the length of the line segment that joins them together. So, the line segment AB. So, the distance between 2 points A and B is represented by like a straight line, AB, and then another straight line. So, the best way to describe or to figure out how this works is just by doing a few examples. So, the first example here I have is we have the point A, 2, -4, and B, 1, 3, and they're 2 points. And what we're going to do is find AB, so the length. And it says here, leave your answer in surd form. Now, surd form, I hope we're all okay with surd form from doing algebra. Surd form is just with a square root. They want you to leave it as a square root, so they don't want you to start changing it so that it'll have decimal points in it. Now, the first thing you do for this is you write out your 2 points. So we have A here, which is 2 -4. And we have B, which is 1, 3. And every time you're doing a question, you need to write them out. Then you label them. So this is what we call X1, and the one beside that is Y1. Then we have X2, and then we have Y2. The next thing you need to do is write out the distance formula. We're looking for the distance between A and B, and that's how it's represented. And then you copy exactly from the formula and tables booklet, X2 minus X1 squared plus Y2 minus Y1 squared. Now, the reason why I got you to put out the points and to label them X1, Y1 is because it'll make your life much easier when you're filling it into the formula now. So, the best thing to do is also put all the points in brackets. So we have X2, which is 1. So this will be 1 minus X1, which is 2. And then that's plus, so Y2, which is 3, minus Y1, which is -4. All of that is squared. Now, the next thing and the easiest thing to do is just type that into your calculator. When you type that into your calculator, you're going to get the answer of 5 square root 2. Now, the second example is very similar to the first example. We have 2 points and we have to find the length of CD. So again, the first thing you do is write down the points. So we have C, which is -2, 1, and we have D, which is 1 minus 3. So this becomes X1, Y1, and X2, Y2. The next thing we're going to do is write out the formula, which we can get from the formula and tables booklet on page number 18, and that is X2 minus X1 squared plus Y2 minus Y1 squared. Now, so then we just fill in the formula. So X2 is 1 minus X1, which is -1 squared, plus Y2, which is -3, minus Y1, which is 1. Again, we just type that into our calculator. We press the equal sign, and you will get an answer of 5. Again, example 3 is very similar. This time though, it says P is -2 minus 3 and Q is 0, 4. And they tell us that these are 2 points. They want us to find PQ. and they say give your answer correct to 2 decimal places. So in this time they don't say third form, they say 2 decimal places. So again, the first thing we do is we write out the points. So we have P, which is -2 -3, and we have Q, which is 0, 4. Labeling the points, so this is x1, y1, x2, y2. Then from the formula and tables booklet, we can take the formula for getting the length of a line. So it's x2 minus x1 squared plus y2 minus y1 squared. Every single time you follow these steps, you write out the point, you label the points x1, y1, x2, y2, and then you write out the formula from the formula tables booklet. That will ensure that you get nothing wrong. So the next thing then we do is we just fill it in. So we have PQ. So we have x2, which is 0, minus x1, which is -2 squared, plus y2, which is 4, minus y1, which is -3, and that's squared as well. Now again, you just pop that into your calculator, and you're going to get an answer of square root 53. Now they wanted to 2 decimal places, so you just need to press the SD or change button on your calculator, and you should get the answer of 7.28. Example number 4 is just a kind of a different way to start the question. So it says the diagram shows the points A and B, and we can see them there in the coordinate plane. CD is also there, so C is 11, 2, and D is 6, -2, and there are other 2 points. And firstly, in part A, it says plot the points CD on the diagram and draw the quadrilateral ABCD. So first of all, C, so we go across 11, which is over here, and then we have to go up 2. So we're going to label this C. And then D is, we're going over to 6, and we're going down -2. So we're going to this point here, and that's D. Now, the next thing it says is to draw the quadrilateral. What you're going to do is you're going to do this using your ruler. For me here, it's going to be a little bit messier, but that's okay. Now, and we have a quadrilateral there. Now, just to make sure, what is a quadrilateral? Hopefully you should know this from junior cycle already. But a quadrilateral is just a 4-sided shape. Now, the second part there, so that's part A done. So the second part there says, show that ABCD is a parallelogram. Now, for a parallelogram, the opposite sides are the same length. So for a parallelogram, we'll have to show that the opposite sides the same length. So we can pick 2 sides. So I think I might pick AB first, and the opposite side from AB is CD. So we have to show that these 2 sides are the same length, and then we'll have to show that AD and BC are the same length as well. So first of all, with AB, we know that A is -3, 1, and B is 2, 5. So then to get the length of AB, we're going to use the formula which is on page 18, and that's going to be x2 minus x1 squared plus y2 minus y1 squared. Again, we are always writing the points and writing out the formula. So next thing we're going to do is, I'm going to maybe do it in a different color pen so we don't get confused. We'll label these. So we have x1 here, y1, and then x2, y2. Back then here we have the length of AB is going to be equal to the square root of x2, which is 2, minus x1, which is -3, and that's all going to be squared, plus y2, which is 5, minus y1, which is 1. Again, you're going to pop that into your calculator. You're going to get the square root of 41. And for the minute, we might leave that the way it is. Now, to get CD, so C is 11, 2. And D is 6 minus 2. Again, CD, we're going to use the formula from the Formula and Tables booklet. So we have x2 minus x1 squared plus y2 minus y1 squared. So again, I'm just going to label the points here. So this is our x1, 2 is our y1, 6 is our x2, minus 2 is our y2. So filling this in then, we're going to get that we have x2, which is 6, minus x1, which is 11. All of that is squared, plus y2, which is minus 2, minus y1, which is 2 squared. Now, when you pop that into your calculator, you're going to get the square root of 41. And if you compare the values, we have here the square AB is equal to the square root of 41, and we have here CD is also equal to the square root of 41. Yes, we need to also show that the other sides are the same length. So the other sides would be AD and BC. Now I'm going to start with AD. So we have A here, which we know is minus 3, 1, and D, which is 6 minus 2. So to get the length of AD, we're going to use the formula on page 18 of the Formula and Tables booklet. X2 minus x1 squared plus y2 minus y1 squared. Again, I'm going to label the points now. So minus 3 is x1, y1 is 1, x2 is 6, and y2 is minus 2. So then we have AD, we just fill it in. So it becomes the square root. Now x2 is 6 minus x1, which is minus 3. Y2, which is minus 2, minus y1, which is minus 1. Again, we're just going to pop that into our calculator, and when we pop that into our calculator and press the equals to sign, you're going to get 3 root 10, which is grand. And then we're going to do BC next. So B is 2, 5, and C is 11, 2. So we need to find the length of BC. We're going to use the formula from the Formula and Tables booklet, x2 minus x1 squared plus y2 minus y1 squared. Next thing I'm going to do is label the points. We have x1, y1, x2, y2, and then filling that into the formula, going to get x2, which is 11, minus x1, which is 2, all to be squared, plus y2, which is 2, minus y1, which is 5. All of that is squared. Then when we pop that into our Formula and Tables booklet, we get the answer of 3 root 10. Now, if you compare what we got when we got the length of AD, which was 3 root 10, to BC, which was 3 root 10, you can see that they are the same. So if we go up here, and it's always when they ask us a question or want us to show that it is a parallelogram, for example, we have, if we go up here, we can write exactly what we need to say. As the opposite sides are the same length, ABCD is a parallelogram. So as you can see from this question, A was quite simple, so it was just plotting points. B, if you weren't sure what a parallelogram is, it makes it a little bit harder. A parallelogram is a type of quadrilateral, and a parallelogram is a quadrilateral that has the opposite sides are the same length. Now, of course, when we're doing area and volume and we're looking at shapes, you'll be able to look at that more too. But I'm hoping that by filling in the formula that this is okay. The final type of question that you could be asked is the one I have here. So we're told here that the distance between the points 2, 3 and 5k is root 10. And it says find two possible values of k. So what we're going to do for this one is use the distance formula that's given on page 18 in the formula table booklet to kind of almost work backwards to figure out what the point is. So we start out the very same. So what we have 2 points. So the distance is going to be equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So we have the 2 points, which is 2, 3 and 5k. So I'm going to label those now. So we have x1 and y1 and x2 and y2. So for this, it tells us that the distance is square root 10. So I'm going to fill that in for the distance. So the distance then is equal to the square root. Now x2 is 5. Put that in a bracket. Minus x1, which is 2. All that is squared. Plus y2, which is k. Minus y1, which is 3. And all of that is squared. Now, this looks a little bit daunting, but if we just take it bit by bit, it's not too bad. So the first thing you might do is you might figure out what this part here is by just typing that into your calculator. So we get the square root of 10 is equal to the square root of 9 plus k minus 3 squared. Now, as you can see here, I've gotten rid of the brackets here because there's no weird signs or anything going on, so it just can stay as k minus 3. The next thing we have here is we have the kind of square root and the square root. Now, I hope you can remember from algebra, to get rid of a square root, what we do is we just square both sides. So then we'll be left with 10 is equal to 9 plus k minus 3 squared. So I'm hoping that is okay. So then we have the bracket. And to get rid of this bracket, we just multiply it out. So this is going to be 9 plus k minus 3, k minus 3. So that's going to be 10 is equal to 9 plus k minus 3, minus 3, k minus 3. So it's how we did that is it's k by minus 3, minus 3 by k, minus 3 by minus 3. So then this is 10 is equal to 9 plus k by k, which is k squared, minus 3k, minus 3k, plus 9. Now, so then this becomes 10 is equal to, we underline the like terms, so we have minus 3k, they're the same, and we have 9 and 9. So 9 and 9, when you add them together, it gives you 18, plus k squared, minus 6k. So what we're going to do is take everything over to the one side, so we have minus 10 from both sides, and we'll get here that this will give us 0 is equal to 8 plus k squared minus 6k. Now this, if you haven't spotted already, is a quadratic, and for a quadratic we always write it k squared plus k plus a number. So this is going to be k squared minus 6k plus 8 is equal to 0. Now I'm hoping you can remember how to solve these. We solve these using our minus b formula. So the minus b formula I'll do over here. And that is, so k is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Now we have it that it's k squared minus 6k plus 8 is equal to 0. This is in the form ak squared plus bk plus c is equal to 0. So then a here is 1. B is minus 6, making sure that you bring the minus 6 with you each time. And C is going to be 8. So filling that in, we get K is equal to minus 6 plus or minus the square root of B squared, which is minus 6 squared, minus 4 times 1 times 8. And all of that is over 2 times a, which is 1. Now, first of all, we're going to look at the positive side. So when we have the positive side, you're going to get that k is equal to 4. And when we have the negative side, we're going to get that k is equal to 2. So the question then says, if the distance between the points 2, 3 and 5k is root 10, find 2 possible values for k. And we've just done that. We found that k is equal to 4 and k is equal to 2. So the accompanying worksheet with this, the coordinate geometry of the line worksheet 2, which is the distance between 2 points, has a few questions on it. Question 1 says, find the distance between the following pairs of points. That's just exactly like the examples that we've seen already. So examples, particularly example 1 to 3, if you can do any of those, you should be able to do all of the questions here. Question 2 then, so A, B and C are the vertices of a triangle. So what we have here is vertices. If we draw a triangle, the vertices are the points on the triangle. So it's given us the vertices, so we should be able to plot that on a coordinate plane. We should be fine with that as well. And they want us to show that AC is equal to BC. And if this is true, the type of triangle that it is it's going to be isosceles. Because an isosceles triangle is a triangle that has 2 sides and 2 angles that are the same. Question 3 then says the points A, B and C are vertices of a triangle. We should be fine with that. We know vertices now are the points of the triangle. It says find AB, BC and AC. That's again exactly like example 1, 2 and 3 that I went through. And then it describes the triangle. So making sure what you have to say here is what type of triangle it is. So we have 3 types of triangles. We have an equilateral. We have an isosceles. And we have a scaling triangle. Now, an equilateral triangle, we have the sides are the same. An isosceles triangle, we've talked about it already. So 2 sides are the same. I'm talking about length now. And then a scaling, so no sides are the same. So that should make that question quite simple. It's probably, or I hope, would cause no issues. Question 4 says, use the given diagram to write down the coordinates of A, B, C and D. We should be perfectly fine with that from coordinate geometry, the worksheet 1. It says show that CD is equal to BA. So again, you're getting the lengths of the lines. And then that's that question done. So hopefully that should be fine. As you can see here, this is also a parallelogram. So this, if it says show that CD and BA are the same length, that would mean that it is a parallelogram. Question 5 and question 6 then are exactly like example number 5. So if the one where we were looking at the distance between 2 points, and it told us what the distance was, and we had to figure out what one of the points is. So for example, in 5 it says the distance between the point 5, 2 and 4k is root 2, and it's asking us to find 2 values for k. So you should be perfectly fine with doing that now that I've gone through that example. And the last one there, x is 3k and y is minus 1, 2, and there are 2 points. It tells us that the distance between x and y is 5, and it wants us to find 2 values of k. So again, it's very similar to example 5. So if you go back and look at your notes where you've taken down the solution to example 5, you should be able to copy that and do question 6 as well. So that's the end of this video for coordinate geometry of the line worksheet number 2, which is the distance between 2 points.